Let's get started with some C+ programming with Linux. I'm using Kali Linux on Oracle VirtualBox virtual machine. Bring up the terminal. Nano is a very simple little text editor built into Kali Linux, so we're going to create the traditional Hello World program. Nano hello world.cpp. CPP is the common extension for Nano. I'm sorry, for C++ programs. Here is the famous Hello World program in C++. We have to include I/O streams so that we can do input and output. All C++ programs are defined like this. There's a main function which returns an integer of either 0 if it's successful or 1 if it fails to the operating system. Because remember, programming languages talk to the operating system in order to communicate and do things. // are comments. std : cout means we're going to the out. We're going to the standard display out, which is the console. We have to have these little redirection characters to send that out to the screen. stdnl ends the line. We return 0 to the operating system. Everybody is happy. Control X to modify. Do we want to save the buffer? Sure. We're going to save the file. Now in G++, an open source compiler is built into almost every version of Linux. So we're going to do G++, and then we're going to compile our file, HELLO. I'm going to do tab completion. Let's see, WOR, there we go, world CPP. I need a -O to say what my object file is going to be. In Linux, we don't need exe. It's automatically an exe if we change the modifications so that it runs. So hello world. It'll compile and then it should be done. If we do ls, there's our program. It's HEL. There's our hello. Let's see, world. It's an executable file. There it is. When we compile something with G++, it automatically makes it an executable file. Notice right there, hello world is green. Green means that it's executable. We have read, write, execute, read, write, execute, read, execute permissions. So we have write, execute, read permissions. Time to make some decisions. So if decision.cpp, we're going to put that, I'm just going to copy and paste the code in rather than typing a whole bunch of stuff. All right, copy, shift, insert to paste. There we go. Let's go up to the very top. We need I/O stream always to do input and output to the standard outputs. Standard output is the console, standard input is the keyboard. Int main, of course, is our main program function. We're going to initialize an integer x to 0, initialize y to 10. We do a standard out and we say that x is such and such and y is such and such. When we're going between strings and variables, we have to put these redirection symbols in order to send the information out of the program to the console or the terminal or whatever you want to call it. Well, this is if x is greater than y, well, then we send out to the console x is greater than y. If it's not x is greater than y, it's not greater than y. And then we turn 0 with the successful completion of the program. All right, let's exit and compile this. We'll save the buffer. And there we go. So I'm going to G++. We say what file we're going to do. If decision, -O is our output file. If CISION takes a moment to compile. And there it is. If underscore D. Oh, I always forget to do that in front of it. There we go. / means that we're working on a file in our current directory. There it is. X is 0 and Y is 10. X is not greater than Y. So now we've made a decision. Well, what's next? Now that we've made some decisions, let's go through some loop structures. Again, IOStream, gotta have it. Int main. We're creating a counter variable as an integer, because while loops do not have a built-in counter variable like the for loop does, which we'll see later on. So while the counter variable is less than or equal to 10, let's see, is that less than? Yeah, it's less than or equal to 10. I'm not sure why it looks so funky in Nano, but it does unless you cursor on top of it. Now we're going to put the standard output counter is equal to, so each time around through the loop, we're going to increment the counter by 1. ++ counter increments the counter before the line is executed. Control X to exit. G++ -O for our output file, which is going to be while loop. Compiles, we do / because we're saying, oh, I want to do work with a file in this folder. There. So it starts at 1, goes clear up to 10. Well, why does it start at 1? Well, let's go back and look. Because we assigned the variable to 1. And while it's less than or equal to 10, it keeps going through the loop. There, 1 through 10. We can now do repeated things with a while loop. Let's go to the do while loop, which isn't used quite as often, but sometimes it's helpful. So let's make a do while loop. We need the code, because I'm not going to type all this in front of you. Control S to save. Let's go to the top. So just like the while loop, we need a counter. However, look where our test is. There isn't a test at the top. So the while loop, you may not even go into the while loop if the test or the if statement, you can think of loop structures as being a repetition statement that has a condition in it. So there's no condition here. The condition's at the end. So we're going to go through a do while loop at least once. In effect, this will be the same thing, because while the counter is less than or equal to 10, we're going to go through this loop. So this is what's called a post loop condition. Let's exit and compile that guy. Whoops, we have to do a G++. And we're going to do _w while -O for our output file. Whoops, -O, not equals O. For our output file. And then we run our file, and we should see exactly the same thing we just saw. We do. So a while loop has a post loop condition. The while loop has a condition at the very beginning. So think of this like an if statement. If this is true, we keep going through the loop. If this is false, if this condition evaluates to false, we exit the loop. If this condition evaluates to true, we stay in the loop. So loops evaluate conditions to determine do they keep going or not. Well, let's exit and create a for loop. For loops are used a lot. A while loop and a do while loop are quite commonly used when you don't know how many times you're going to go through the loop. For loops are very good at going through a loop exactly the same number of times when you know how many times the loop needs to run. Same IOStream. Here is the syntax for a for loop. We initialize our counter inside the first semicolon. we do our condition test. So it is possible we may never go through this loop. If I initialize this counter to 11, it'll never go through. Each time the counter increments. It does not increment the first time. This one runs only the first time through the loop to initialize the counter. Every single time it does the condition checking, is counter less than or equal to 10? And this gets incremented after the loop is complete. Maybe a better way to say that is this is not incremented until we go through the loop at least once. Yeah, that's a better way to say it. So we're going to use the modulus operator to determine if a number is even or not. Well, how does that work? Well, 2 modulus 2 is 0, right? Modulus is the remainder after you do integer division. So there is no floating points, there are no decimals. So 2 modulus 2, there is no remainder because 2 goes into 2. 3 modulus 2 is 1 because 2 goes into 3 once. 4 modulus 2 is 0. 5 modulus 2 is 1. Well, you can see where this is going. We get only the even numbers each time. It's a very common algorithm for determining odd and even. So we do our for loop, minus O, compile it. If when you're compiling something goes wrong, sometimes it'll tell you what's not right. You just have to go to your code and figure out what in the world happened. All right, so /for loop, and there it goes. It goes through and counts the even numbers between 2 and 10. This was a simple little tutorial just to get you up to speed and started compiling programs in Linux. I'll have some other tutorials later on where we do a little bit more C++ programming. This is getting started with C++ in Linux. See you later.